Hi, this is Keely, and we're going to do a little lab where we're going to use that spring and these masses and mass holders to simply draw a graph about the mass we put on there and how much that spring stretches. And so it's not quite Hooke's law, but it'll give us some data to graph and maybe take a slope. So it's still useful. So here we go. Okay, I first set this up so if I take the weight off this, that line should be pretty much at 0 centimeters. Now this mass holder is 100 grams. So our first point is pretty much 0, 0. At no mass, the spring doesn't stretch. But then when I have 100 grams on there, it stretches that amount. We're going to use this wire up against that centimeter scale here to measure the stretch. And so that is the stretch. Let me zoom in a little bit more. For 100 grams. So let's add another 50 grams. There's the stretch with 150 grams. Let's put another 50 grams on there. Total of 200 grams. Adjust the camera just a little bit. Zoom back in. Let's add another 50 grams, so a total of 250 grams. Look at the stretch. Another 50 grams, total of 300 grams. Let's get a little bit more mass on there. So we've got 100, 200, 300. Let's go to 350 grams. And let's do 400 grams. So a total of 400 grams on the spring. That's how much it stretches. Okay, zooming back out. So now, take the data. The mass is our independent variable because that's what we control. The stretch is what happened. So that's our dependent variable. Graph it, figure out your scale, plot your points, do a line of best fit, and then take the slope of that line. Because that slope will tell you something interesting about that spring. Thank you. And though this is not quite Hooke's law, it's a good graphing activity. So we'll do another lab later on and get more serious data. All right, thank you. Bye.